When looking at a function, and we want to analyze how much the function is changing, what we're doing is looking at the rate of change of the function. We can determine the rate of change between 2 points, say this point here and this point here, or we can determine the rate of change at an individual point, let's say there. When we're looking at 2 points, we're looking at the average rate of change between those 2 points. When we're dealing with this rate of change, we generally use the lower value being called A and the higher value being called B. This is along this axis here. The reason for this becomes evident when we put it into the formula. Now, looking at the formula for the average rate of change, which is given by the function evaluated at B minus the function evaluated at A divided by B minus A. When we want to figure out the rate of change at an individual point on the function, we'll call this point C. What we're doing is finding the slope of the tangent at that point. This means that we can calculate the derivative of the function at that point to give us the instantaneous rate of change. So now let's look at an example of calculating these rates of change. So let's look at the function f of p equals p squared plus 2. And we want to find the average rate of change between when p equals minus 5 and p equals 2. So first we'll evaluate when p equals minus 5. So f of minus 5 equals minus 5 squared plus 2, which equals 25 plus 2, which equals 27. Now we'll evaluate f when p equals 2. So f of 2 equals 2 squared plus 2, which is equal to 4 plus 2, which equals 6. Now that we've calculated this, we can put it into the formula. So the average rate of change is given by our function at 2 minus our function at minus 5 over our 2 points of 2 minus minus 5. So now we can put in our values that we calculated, which is going to be 6 minus 27 on 7, which is minus 21 on 7, which is equal to minus 3. What this means is that when we're looking at our function, which is roughly given by this, and we look at our 2 points, the average slope between those 2 points is negative 3. So now let's look at the instantaneous rate of change. We know the instantaneous rate of change is given by the derivative. So f of p equals p squared plus 2, and f prime of p is going to equal 2p. Now let's look at the instantaneous rate of change at the 2 points that we've chosen. So that was when p equals minus 5 and when p equals 2. So now we can just put that into the derivative, which is f prime of minus 5 equals 2 times minus 5, which is going to be minus 10. And then we'll put that in at f prime of 2 equals 2 times 2, which is going to equal 4. So what this means is that when we're looking at our function, And at the point p equals 2, we can see that the rate of change is positive and 4, which you can see in this graph. And then we're looking at the point p equals minus 5, we can see that it has a negative 10 slope. This is our instantaneous rate of change, and it follows the shape of our function. Compared with the average rate of change, which is minus 3, that travels between these 2 points, they both give very different pictures but reveal the same information about what's happening with the function.